Okay, so yes, 4.5 quadratic equation. The only difference between this section and 4.4 is you'll see we have equal 0. So what that means is this is a parabola, right? X squared, it's a right side up parabola because the A term here would be positive 1. That's how we know it's a right side up parabola. So what we're trying to do when we solve for x in these problems is figure out the two spots where the parabola crosses the x-axis. This parabola will cross the x-axis. It's going to kind of look like this. So this would be the y-axis. Here's the x-axis. It's going to cross at 2 and 3. So we're going to prove it mathematically that the x values that will equal 0 if we were to plug them in will be 2 and 3. How do you do that? You just factor, right? Some of you guys really like the cross part of the Indian method. You can always do this cross part if you want. So here is 1 c is 6. 1 times 6 is 6. The b term is -5. -5 goes on the bottom. Remember, it's what multiplies to the top and what adds to the bottom. So factors of 6, all we have is 1 and 6 and 2 and 3. Realize my c term is positive, my b term is negative. When that's the case, they're both negative. Good. Okay, so we have 2 here, 3 here, both negative. Right, so then double check, right? -2 plus -3 is -5, and a negative times a negative is a positive. 2 times 3 is 6. Okay, so you know you got it right. Now, if we just do the cross part, right, we don't have a number in front of the x squared here. So if we're just doing the cross, we already have our parentheses. You don't need to do the fraction part of the Indian method. So it's just like this, x minus 2, x minus 3, they both equal 0. Okay, normally what I'll do is I don't show that step. I just show the next step in line, and I'll do that for the remainder of the period. X minus 2 equals 0, and x minus 3 equals 0. Because I'm going to have to set them equal to 0 anyway, so I just skip that step above normally. Now, this might seem like a stupid step to show, but I just graded a bunch of your quizzes. You guys showing me as much partial credit as you possibly can will help you get a better quiz grade, right? So show those stupid little steps. You might catch yourself making a stupid sign error or something like that. So why wouldn't you show this step, especially on the quiz? And even on the homework, you want to practice these skills that I teach you. So do this on the homework as well. Like show every step you would show on the quiz on the homework. Because if you do it the same way, you're more likely to do it correctly. So x equals 2, x equals 3. We're going to look at that in the graphing calculator as well, just so I can prove to you that's how it works. So we're going to throw in x squared minus 5x plus 6 into the y equals. And then don't always hit Zoom 6 to graph. I'm going to hit Zoom 6 this time because I know my window's messed up from earlier from last period. So I'm going to hit Zoom 6, which gets me back to that regular -10, +10 window. And then you can tell, yes, it does. It crosses right here at 2 and right here at 3. Okay? You can always do that to double check your answers when you're doing these problems, even when you're just factoring. Right? So if I go back and I'm looking at, right, I can think -2, well, I know that's going to be +2, -3, I know that's going to be +3 over here, and then graph it to double check on a quiz. Right? If you are double checking your answers on a quiz, you're building your confidence. Right? If you never check your answers on a quiz, then you're increasing your doubt. Right? And we've all been in that place of increasing doubt in our life, personal life as well as academic life. It's not a good place to be. Nobody needs to be there. So double check your answers. Okay, here's one I'd like you to try on your own. Realize you got to add the 12 over to the left side of the equal sign. So it's going to be +12 equals 0. So factor it, set up your two parentheses, and then set those parentheses equal to 0. Once you're done at home, do the little virtual hand raise thing so I know. Don't inhale coffee. So this is that step I skip, where I don't just show the parentheses equal 0, because I'm going to do this anyways, and then add 3 to both sides, add 4 to both sides on this equation, and we get x equals 3, and we get x equals 4. Okay, take your little virtual hand raising down, raise your actual hand if you got it right, in person or at home, and I see a question as well. Okay, good. Question?
Do we have to draw every single time?
No.
No.
I mean, you do this problem and you're very sure you get it right. Now, on a quiz, I would graph it to double check, but on the homework, you're good. You can check solutions to make sure you got it right. Okay, write this one down. So this one, when you have a quadratic binomial, right, start ingraining those words into your head. Quadratic because of the x squared, binomial because 2 terms. Okay, second term being an x term, that's where we have to factor a greatest common factor out. So here's how I think about these things. I look, they're both even. I know I can divide by 2. Then I think, can I divide by anything more? This one's super obvious. What can you divide by? 12, right? Because 12 divides into 24. It's just really easy to see. It's not always really easy to see, right? So just know that. No big deal. 12 what can I divide? 12x. Okay, so we take that 12x. That's what goes in front of the parentheses. I forgot the x. 12x. And then we just reduce that first fraction, right? 12x squared divided by 12x is x. Negative 24 divided by 12 is negative 2. And then the x's cancel. We still have the equal 0. Don't forget that. So now we have to take both parts, what's in front of the parentheses, set it equal to 0, and what's inside the parentheses, set it equal to 0. So I say 12x equals 0, x minus 2 equals 0, add 2, so x equals positive 2. Right? If I'm taking my own quiz, I show that step. Because I know when I'm the kind of student, I should have gotten 100 on almost every single math class I ever took, like I had the knowledge. What screwed me up is that little half-point deduction. Right? How many people got a little half-point deduction on that last quiz? How many people did that just make you want to scream, that half-point deduction? I know for Hannah it did. Right? You missed only 0.5 on a quiz, and you're like, ugh. And like it's always something really just like, I can't believe I forgot that kind of thing. Or you get mad at me and you're like, you took points off for that? Hell yeah, I did. I will always, right? So you guys know, just in general, high school kids want to be treated the same. That's the most ridiculous thing I've ever heard. Are you all the same? Hell no. You're different shapes and sizes and colors and intellects. So I treat you all differently. If you're an A student in my class, I grade your quizzes harder, right? If you're a D student in my class, I'll give you a little break here and there because I'm trying to get you to do better, right? So that's how I grade. Nobody has ever complained about it. Like if I say that, if I said it to Neil, he might freak out. Hell no, I don't grade the same. Why the hell would I? You're all different, right? So when you factor out, this is the point I want you to understand right here. That, what I just highlighted in pink, is called a monomial, right? A single term is called a monomial. You can have a number and a variable multiplied together. This could be like a million, the 12 could be a million, the x could be to the 108th power. If I set that monomial equal to 0, my answer will always be 0. Okay, so when I factor a monomial out, I'm always going to have 0 as one of my answers. It's just kind of helpful to understand that. Not essential that you memorize that or anything. Just know, don't get freaked out. It shouldn't be surprising, right? Anytime you factor something out, it's just an equal to. Okay, so this one says solving a quadratic with tables. This, in my opinion, is the stupidest method of the whole day. Okay? So I'm going to show you why. We're going to go into the graphing calculator, put 5x squared plus 30x plus 14 into y1, and we're going to put 2 minus 2x into y2. So make sure you write the equations down as well so you can go back and look at them. And I'm going to get off the screen and start entering it. So it was 5x squared plus 30x plus 14. And 2. See, it always gets to like a random one. I never know. We're going y4 for me. 2 minus 2x. It doesn't matter where you enter it. It all works out. So remember, the most common mistake I see with you guys entering stuff into the calculator. So you'll see where it's blinking my cursor. That negative is like broad. That's a negative. That's a negative. This is a minus. If you have it with a negative, if your graph is wrong. Okay? So make sure you have that minus. I'm going to hit zoom 6 to graph. There we go. Look at your graph if you didn't get it. 5x squared plus 30x plus 14. Normally you get to miss an x if your graph doesn't look like mine. And then I'll help people. Shade? Oh, get rid of the shade? Yeah. So hit y equals. Go to this one. Go over there, enter, and go down, right there, and just wait till you see the line. That's got it. There you go. Yep. Anybody else need help? Good? Okay. So we need the 2 places. All right, let's have a little moment here as well. If I have x squared, how many answers do you think I'm going to get? Common sense would say 2, right? So if I look at my graph here, I'm looking for 2 places where the line intersects the parabola. I can't see the second place because it's up higher. So that means I want to increase my y what? Y max. So I'm never one to increase it to like 12. I find that stupid. I'm going to double it because I don't want to have to keep going back to the window. I just get irritated. So I'm just going to do y max of 20 and see if that works. It does. So we want to know where the line and the parabola intersect. Second trace. You need to write this down, calculator steps. You should know second trace intersect anyways. We're actually going to do this with tables and second trace intersect. So you can go down to number 5, hit enter. So we have 2 intersection points. It will always start on the parabola. You can look up here. It tells you it's in the y1 equation. If I hit the down arrow, then it switches to my beautiful magenta equation. Right? It's easier to go along the line if you're on the line as opposed to the parabola. So I just want to move my cursor to one of the 2 intersection points, hit enter. Then it says second curve. I'm still near the intersection point. I'm good. Enter. Says guess. Enter once more. So this thing crosses at negative 0.4. That's one of our x values. If we were to go through and factor and solve, negative 0.4. Question, Katie.
Oh, that one. Okay, I got it.
You good? Okay. I saw that for a brow, so I figured there was a question. Okay. So I'm just going to copy this so we get the intersection points in the notes. So we have two x values for our answer. First x value for our answer, right? We know we need two answers because it's squared. Negative 0.4. Then we'll get the second intersection point. Second trace, number 5. Now on the parabola, I like moving along the line, so I hit the up arrow to move to the line, and my cursor will go along the line. And I just have to be near where it intersects, right? The only thing you could screw up is if you put the cursor like right in the middle, but none of you are that stupid, right? You're all smart young people, so you'll put it where it intersects because that's sensible. Yes, one more. So negative 6 is the other intersection point we want. So negative 6 is the other. Now, I'm going to show you why we just did this the way the example told us not to. So I got the intersection points. They want us to use tables. I'm going to show you why you shouldn't use tables now. I'll have you do it this way on your quiz because I find the table stupid. I just have to teach it to you because we'll use tables some in the future. So if we just look at our table of values, let's actually hit second window. And all of you, I want you to read above the window button and see what it says. What does it say above the window? Table set. So if I want to set my table, second window, right? Because that's how I get the table set. So my table starts currently at negative 5. I'm going to look at my graph real quick and just count over. So negative 1, 2, 3, 4, 5. So I want my table to start at less than negative 5, so I'm just going to say negative 8. You could pick negative 6, that's fine. Now my table, this tells me what my table is going to go up by, so it's going to go up by 0.5 each time. So if we're starting this problem, you're going to have no idea that one of the two intersection points is 0.4, right? Let's say we have no idea. I have no, generally we'll have our table go up by 1, and we'll look at the table by hitting second graph. And we're looking for where x has a value and y is 0. Let me see that right. Yes, x has a value and y is 0. See, isn't that confusing? Just looking at it? Why the hell? We need to get negative 6. Oh, that's how it is. That's even worse. So negative 6, when these two are the same, that's one of the zeros. Right? So if I know one of my answers by doing it the sensible way is negative 0.4, looking at the tables, what I have to do is go back to table set, make my table go up by 0.1, which is a total pain in the neck. And then I hit second graph, and then I would have to scroll all the way down to negative 0.4. Way too fast. Wow. The thing just went crazy. We'll go a little slower this time. I'm curious what it's going to be, negative 0.4, what I'm trying to get to. So you can imagine if you had no idea that you had to go by 0.1, right? You started once, you can't find the other zeros, then you're like, oh, maybe 0.5 will work. Nope, that doesn't work either. And then you have to go to negative 2.4 and look for these two numbers to be the same to know that's a 0. Screw that. I don't want any part of that. Now, you're still going to have to work with tables eventually, but that's why I would not I would do it with this method, getting the intersection points. I think is way easier, right? So problem 2 and problem 3, problem 2 in your homework will say use tables. You can do the intersection thing. I'm not making you use tables, okay? In problem 3, you're also going to use just like, so let's do problem 3. We're going to put, I'm just curious, I want to see if this works. So I'm going to put y1, just separating the sides of the equal sign, right? So y1, I'm going to put in 2x squared plus 7x. That's going to be a parabola. If I put just 15 into the y equals, that's going to be what? A horizontal or vertical line? Put your thinking caps on. Horizontal, we have with the questioning tone. Show me at home, horizontal or vertical for equals 15. We got a lot of this going on at home, right? So let's see. Let's put it in. So we're going to put in 2x squared plus 7x into y1. And then for me, it's forcing me into y4. So I'll put my 15 there. And then I know I have to adjust the window again, right? Because that's going to be a horizontal line that crosses at 15 on the y-axis. Well, I already got 20, so actually I'm good. So you can keep your same window. Shazam, right? So you just have to have something over on the other side. I was actually telling my 5th period students you have to have an X term on the right side. You don't. You just have, it's honestly easier if you have the number, right, to get the intersection point. So we just do it again, second trace number 5, and for sure go along the line, way easier, not the parabola, enter 3 times. So second trace number 5, move your cursor, enter 3 times. If you're the kind of person that needs calculator directions, that's a good thing to write down. To get the intersection points, plural, second trace number 5, move your cursor to one of the 2 intersection points, enter 3 times. Bang, bang, bang. So 1.5 is one of our answers. And we'll go second trace number 5. Notice it's up here on my parabola. I want to move it so I get the down arrow, and you can see the beautiful magenta. And I just have to be near. Like the only thing that you guys would do to screw this up is you put the cursor like right in the middle. But none of this, yeah, that's not happening. Enter, enter, enter. So negative, what was it? Negative 1.5? Was that the first one? And negative 5? 1.5 and negative 5. Okay. So x equals 1.5 and negative 5. So if we have the parabola, what that means is over here, negative 1, 2, 3, 4, 5. That's one place it crosses, 1, 2, crosses right there. Is this parabola right side up or upside down? Right side up, because A is positive, so your parabola is going to look something like that. We don't know how far down the vertexes can go unless we do the negative B over 2A, but just a general sense of what's going on by doing that. Do number 3 with the intersection. You can add or subtract over whatever you want to the right side. I think if it were my choice, I'd add the 24 over. I just think it's easier to get the horizontal line and the intersection point. We're almost done with the lesson, by the way. One more story problem about frogs jumping. Michael Jordan of frogs coming up. You'll see. I know, right? Really parabolic math you're doing. You can impress your parents by those words. They'll be like, what? Are you speaking French? No, it's math.
No, it's math.
They're like, what? It is not. It's the best if your parent is not good at math and they think you're also not good at math and you just throw some of that verbiage at them. They'll just like look at you in a totally different way. So for your two intersect, how many people look at that problem? Stop looking at your calculator, look at that problem, do it in your head and tell me what x equals. Oh, yeah. You can do it. I literally looked out at the people in person and I saw quitters. I saw like a room full of quitters. You looked at it and you're like, F that, I'm not doing that. No. What multiplies 24 adds to 2? 2 factors to 24 that are 2 apart. 6 and 4, which one's negative? The 6 or the 4? You did questioning. How do you know? B is positive, bigger number is positive. 6 is positive, 4 is negative. Then you think of the parentheses, opposite sign. So instead of positive 6, once we add that 6 over, or subtract the 6 over, it'll be negative 6, positive 4. Did you get that in your calculator? Little Trevor was trying to follow along. He was just like, what the hell happened? I'll show you just what I visualized in my mind. That's all you guys can do that. And again, we're just trying to set the stage. So if I look at this, I'll do it by hand. So I get x plus 6 equals 0, x minus 4 equals 0. So x equals negative 6 and positive 4. I would venture a guess that like 75% of you at least could do that in your head. Right? You're just not quite ready for it yet, but that's kind of a place where you want to head mentally, because it just makes your math life easier. Right? So that would be it. All right, Michael Jordan frogs.
Nice.
Here it is. It's a good jumping stance there. I'm rewriting the equation just so it's easier for you to see. I'll never forget my godfather. He was an incredibly unique human being. Had one of the most epic beer bellies of any human on the planet. That's one thing. He was like scared of frogs. He turned 50. I grew up at this like kind of a house in the country that had 87 acres. Super fun place to grow up, except your friends were like 45 minutes away. That part sucks. But it was fun to have all the land to cruise around on. We had a pond behind our house. We had gigantic bullfrogs in the pond. My godfather, deathly afraid of frogs. For his 50th birthday, we gave him this box, like a shoe box. He's like, I knew I was in trouble when I saw the holes poked in the side. And there was a frog, I kid you not, like easily that big. The thing like stretched out was at least 1.5 feet. And that thing, like as soon as you open the box, of course freaks out and jumps out. Just absolutely scared the shit out of him. So funny. And then he also loved, like, a little weird, I thought. He loved marching bands. So you know what my dad did? We had like a football field length driveway coming up to our house. He hired like the local high school to march down the road, down my driveway for my uncle. And he was like so excited he started crying. Like it was the cutest thing you've ever seen. I'm like, really? Marching band? And here I am, the a-hole, putting a frog in a box, like giving him a heart attack. It was awesome. Okay. Let's throw this in y equals. We need to answer how far did the frog jump. Okay, they're in a frog jumping competition. I would pay like $100 to see a frog jumping competition, just because it would be that funny. What a bunch of weird people. Oh, no, that's not what I want to look at. 159x So let's start at zoom 6 or standard window. So we need to know how far the frog jumped. So we need to know where this parabola is going to hit the ground, like somewhere over there. So we got to at least double our x-max, right? Because I can't quite see the top of the parabola. We know that's positive 10. So I'm going to take my x-max out to 30. The y-max is fine because I can see the top of the parabola. So if I increase my x-max to 30, then I can see the whole thing. So this starts at 0 right here. I want to know where it hits over here. So this is another calculator direction moment. So get ready. So what we're trying to find here, let me just copy this. So we're trying to find how far it jumps to this point right here. That point is called a 0 because x has a value, y is 0. So it's like some number for x and 0 for y. That's why it's called a 0. So in the graphing calculator, we go second trace 0. So second trace number 2. Number 2 says 0, so second trace number 2 is how you figure out where it hits the x-axis. That's what you should write down. Now it asks you this question, left bound. Well, that's confusing, isn't it? So let's talk about left bound and right bound. So let's say we have a graph like we do with the frog jump. It's like that. Let's say conversely we have a graph that's more like that. So how the hell do you figure out where left bound and right bound is with these things? So let's talk about, I want to fix this graph a little. So I want to figure out this point where it hits the x-axis, and then I have to do a whole nother second trace 0 to figure out the point on the right side. So, you know, in the Army, you march left, right, left, right, left, like that. It works on this too. Left is below, right's above. So left comes first. It's left is as it relates to where it crosses the x-axis. So it goes left, right. So up here is going to be left bound. Down here is going to be right bound. So this works with a negative x squared kind of graph. It also works with a positive x squared kind of graph. Same concept. So as it relates to where it crosses, left is above, right's below, left's below, right's above. So when we do second trace 0, essentially, we're trying to surround the x-axis with the cursor. So in practice, this is what I mean. It's a good thing to write down because it confuses kids massively. Hopefully you can make it look better than mine, but you know. So second trace here, we have left bound. We're trying to get this intersection point. So left bound is above, right bound is below the x-axis. So I move my cursor. Doesn't matter, again, I just have to be above the x-axis, like that's above, like too close for my comfort. So I'm going to move it back a couple so I know clearly it's above. I hit enter. It asks me the question down here, right bound. Just clearly below the x-axis, enter. It says guess, enter once more. So that frickin' frog jumps 20 feet. Like, that's insane. That's like from my door to the wall, 20 feet. Like, no, that's not possible. But who knows? Michael Jordan the frog, like I said, right? So 20.34, how far did the frog jump? 20.34 feet. Now, you know me, if I give you a question like this on your quiz, I'm not going to just ask you how far it jumped. I want to know how high it jumped as well. So we're going to figure out how high. How would you figure that out? with the graphing calculator? Second trace what? Be confident, young people. Max. Second trace max. I think it is 4.
Yeah.
So second trace max, right? Because it's a negative A, it looks like a mountain. Mountains have a max. Second trace number 4. Left side of the vertex. You guys can hold your button down. Right, so I look for this tiny little flat spot, and I just want to be on the left side of that flat spot. Hit enter, break down, right side of the little flat spot. Enter guess, enter once more. So that frog jumped 3 feet high, right? Y is how high? 3 feet high. Got a moment. 3 feet high. Okay? So that means the frog's like that high, 20 feet. So it never got above like the chalk tray thing. And it went from the door to the wall. Like, hard to imagine, right? Again, Michael Jordan of frogs. Okay, that is it. Your homework is right here. It is, I don't remember, I will tell you. Page 229, 9 through 35 odd, 36 and 37. I'll read it in the middle. 9 through 35 odd, 36, 37. Okay, so I got a little more battling to do. My battling involves second semester. Missing work due this coming Monday at midnight. Okay, so some of you have sent me emails like, oh, can you put that missing stuff in? I'm still grading quizzes. I put missings in like kind of when I get to them. That's low on my priority list. They will be in before the semester ends, obviously. I plan on getting them all in by Monday night. So turn them in. Don't save all your missings for Monday because, my God, that just sucks. Like, try not to procrastinate. If you have 10 missing, do 3 a day. 3 today, 3 Saturday, 3 Sunday, turn them in Monday, you're good. Do 3 Saturday, 3 Sunday, 3 Monday, turn them all in, you're good, etc. Right? So don't kill yourself with those missings. So missings are due Monday at midnight. Semester ends Friday at 4. Okay? My grades aren't due until the following Wednesday normally. I'll have all my grades in done Friday at 4. Right? Because I like to have a little time to not have to think about grading your stuff. So just so you know that, Friday at 4, I'll have everything done. Next semester, right, we've got 1 week before spring break, semester 2 starts, quarter 4 starts. 1 week before spring break. So the way quizzes are going to work in second semester are more like a normal Algebra 2 school year. If you're in person, you will not be able to use any notes. You will not be able to have any little like 3x5 index card of formulas or anything. You must have everything memorized, ready to go to take the quiz. So naturally, right, I think like a little weasel, right? I'm a devious mind. So what I would think is, why the hell would I come to school on a quiz day? I would just stay home. Because I can use whatever the hell I want at home. So what do I do to combat that? Because I'm smarter than your average bear. What I do to combat that is the quiz you will get at home is going to be nasty, right? I'm going to make it easily twice as hard as the quiz in person. So what I'll do to make that fair, right? This is all about fairness, because God forbid we're not fair in Boulder Valley schools. What I do to make it fair is I will equalize the averages with a curve. Okay? I will not curve those of you in person. I will only curve those of you that are at home only. So if the average in person is 75, it's kind of a regular average for an Algebra 2 class. The average at home is 65. I would add 10 percentage points to everybody who takes it at home. So the averages are the same. So that's a disincentive to stay home. You're not screwed, right? You can still stay home, like I get it. If I wasn't vaccinated, I have asthma, I was a kid, I'd be like, maybe I'll just stay home. But I'm also a social person, so I like the interaction with others, so I'll probably come to school anyways. But just so you know, next semester, you get nothing. No notes, no formulas, nothing. You must memorize everything. If you're at home, quizzes will be twice as hard. Okay? So the quizzes that you currently have, just think of the hardest problem on those quizzes. That'll be every problem on the quiz. Okay? If you're in person, it'll look exactly like the quizzes you've had so far, except you're not going to have notes, right? So the difficulty level is the same if you're in person. The harder part is you just can't use notes. Questions? You'll still have quiz reviews. Not always, but I try to build those in as I can. And I'll probably space out the quizzes a little more, which then gives me a little more time to do quiz reviews. So we'll have larger quizzes, and we'll have some shorter quizzes. Like I might give you a 2-question quiz at the end of the lesson that like bam, bam, multiple choice, you'll answer, I'll grade like in the moment, get them back to you. Because it's good to have those kind of, I call them lesson checks, to make sure you understand the lesson I just taught. But in general, the regular quizzes will be larger, like cover 4 sections maybe, and you might have a couple little short ones, like 2-question quizzes along the way. Okay? The bigger quizzes will be worth more points, little checking quizzes worth less points, obviously. Any other questions about that? So don't, like, I say those kind of things that I freak you all out, right? I just increase all of your anxiety level. What I say is man or woman up, and take that as an exciting opportunity to learn more math. That's a total math teacher thing to say, I understand, but that's how I view it. Like, you will learn more math, you will be more prepared when you take pre-calculus. That's a good thing, okay? That ends my